So welcome everybody. Really appreciate everybody coming here today, and just wanted to say this is a super exciting time for us here at Microsoft, and especially for those of us working on the Project xCloud team, because we have the opportunity to be part of defining the next generation of gaming, as well as gaming experiences. My name's Gus Apostle. I'm a program manager on the xCloud team, and I'm just curious here, we've got a lot of people here today, how many people know what Project xCloud is or have heard of Project xCloud? Wow, quite a few. Awesome, okay. Well, we're here today to talk to you about what is Project xCloud, what are we thinking, what are we working on, and most importantly, give you a little bit of a peek into the future and where we're headed. So Microsoft at its heart is a gaming company. I don't know if many of you know this, but our very first operating system, Microsoft DOS, actually shipped with code to support games. So we've been in this business for over 40 years, and it's in our DNA. And we've actually invested in the console market for over 20 years. So we have lots of experience there, as well as having some amazing game studios that are churning out content and games that people just love to play. So I wanted to talk a little bit about what's driving us and what's shaping some of our vision as we move forward. As many of you know, the game industry is growing and changing at a rapid pace. And I think the venue and the number of people here at GDC is a great testament to that. There's more games on the market, there's more devices on the market, there's more people playing games in new and interesting ways. Social media is playing a big part in how people are consuming games and the gaming experience. So in response, Xbox set out to build a new and innovative game streaming platform, which we call Project xCloud, hosted in Azure, which delivers a set of robust services designed to enable gamers to stream their content to any device wherever they're connected. Now, there's three things that I'm hoping to leave you with today and to walk away from this talk. Number one, we're building a platform that will enable you, game publishers, game developers, to reach your consumers at a global scale. Number two, be able to write your games once and leverage them across multiple devices. And number three, do all of this with the existing skills, code, and most importantly, the content that you already have. So today we're envisioning a world where anyone can access your games, as I said, on any internet-connected screen. And to do this, we need to deliver a platform which offers a console-quality gaming experience that transcends devices and enables you to reach your consumers at a global scale. So why is this important? Well, today, there are 7.6 billion people in the world, and of those, about 4 billion are internet users, and of those, 2 billion are gamers. 2 billion gamers in the world. We're offering the opportunity for you to reach 2 billion gamers. So how do we do this? First, I think we have to look at what some of the game industry research is telling us about how gaming is changing. In 2019, game revenues all up are projected to exceed $150 billion in opportunity. Mobile gaming is going to be a key factor in driving that number and will continue to grow at a rapid pace. And this is largely due to mobile infrastructure improvements, hardware improvements, and more competitive and immersive games in the mobile gaming space. Today, gamers are playing on multiple devices, not just a single device. But oftentimes, those games don't transition well or seamlessly from device to device, and that could cost you screen share. There's also, as I mentioned, a social phenomenon where we're seeing more people actually watching games than playing the games themselves. I watch my kids, they sit in front of their Xbox, they load up a game, and they're playing the game, and on a different social media channel, they're watching a popular gaming personality talking about that game, and on a completely different channel, talking with their friends about the same game, and they're doing this all at the same time. And all of these social media channels target mobile first. So the social media is definitely entrenching itself in gaming, and it's going to play a big part in shaping where gaming is headed in the future. All right, so where are we headed at Microsoft and for Project xCloud? Our mission is actually a promise that we make to consumers that you can play the games you want with the people you want on the devices you want. And what's implicit about this promise is a promise to you, game publishers and developers, that will enable you to create the games you want for the consumers you want, for the devices you want, without having to learn a bunch of extra skills and tools to take advantage of that. So there's three things that I think that we need to address to accomplish this, and that is content, community, and cloud. So let's start with content. If you think about content, it's really about leveraging your existing games that you have over a new set of consumers that you wouldn't otherwise be able to reach. And this could be because of geographic limitations, mobile infrastructure limitations, or simply not having a gaming device available to you when you're on the go. Now, as you're probably aware, consoles and mobile devices have different device characteristics and input characteristics. And these attributes can significantly impact how your game plays when it's being played on different device types. And so we're exposing a way for you to take advantage of the knowledge of the device that the game's being streamed to and use that knowledge to help change or enhance your game's playability. So next, it's about community. Now, community is extremely valuable when you're in a very competitive market like gaming, and you've probably spent lots of time, money, and resources around building up massive communities for your gameplay. Our proposition is that you take these communities with you as you make this journey into the cloud. Start with these communities and bring them along. Sure, we're going to be playing console games, but this opens up a new channel that we can leverage across that group of people. And finally, we want game developers to be able to leverage the power of the cloud. So we're building around a strategy which promises to make it easier for you to reach these new communities in new markets. So what's this strategy? I think it's pretty straightforward. First, put the Xbox in the cloud, right? Take the hardware architecture that you already know how to build on and leverage it by putting it in racks and putting it in the clouds. Cloud. Second, enable you to stream those games. Provide a set of services that lets you stream those games to different devices. And then third, provide a set of tools that lets you fine-tune that game's experience to adapt to the device that it's being played on. And then finally, offer a future at Microsoft scale for game streaming. I mean, what would you do if you had access to the largest global public cloud in the world? Well, we do at Microsoft, and we intend to be playing games on it. All right, so one of the key elements that we have to solve for, and I'm sure this is on top of many people's minds here today, is latency. So to do this, we need to close the physical gap between your consumers and your games. Now, Azure's been solving this problem for hundreds of industries globally, and because xCloud is built on top of Azure, we can take advantage of many of those capabilities and learning to solve the latency and bandwidth problem, and therefore bringing your games closer to your consumers. Building on xCloud also means that you can take advantage of Microsoft's rich ecosystem of products, platforms, technologies, and services, as well as leveraging Xbox and Xbox Live, 20 plus years experience in that space to do so. So today, Microsoft Azure operates in 54 regions around the globe, and that's hundreds of databases. Hundreds of data centers, which is the largest global footprint. And we're pushing into new geographical regions every single year. Microsoft's global network is one of the largest and most innovative on the planet and includes over 161,000 kilometers of terrestrial fiber and subsea cable that we own and we operate to bring services to your consumers. Okay, so what are we building? A couple of points on what we're building. We start with the customer. The customer's at the center of everything that we do. As I mentioned, Project xCloud is a game streaming platform that you as game publishers and game developers can take advantage of to build a game streaming business on top of. Secondly, content. It's about leveraging your existing games that you have into the cloud. Now, we're going to be focused primarily on Xbox One content as a starting point, but our hardware is architected such that we can serve any content to any device that's connected. And think about this. What if I could take a very high-end PC game and stream it to a low-end PC or a lower-grade PC? I think that would be a very compelling story. So next, our customers are you, as I've mentioned, the game publishers and the game developers out there who want to build a game streaming business powered by xCloud without losing your branding or your direct connection to your customer, which is so valuable, again, in this competitive market. All right, so before we go on, I've got two colleagues that are going to come up and talk with you about several things around being able to enhance your game's playability when it's being played on different devices and how we're going to enable you to do these things. But I wanted to put a couple of terms up on the board and define these because you'll hear these throughout the rest of the talk today. So the first is console native. We use the term console native to refer to games that were designed to run natively on the console and then move to the cloud to be streamed without having to make any additional modifications to the game. Remember, these consoles that are in the cloud are the same ones that are in your living room. They've just been enhanced to run in a cloud and in a data center. Second is touch adaptation. This is simply enhancing input by using glass controls and touch overlays. And my colleague Brandon today is going to talk with you in depth about how you can do that for your games without having to crack open your game bits to do so. Now, there are going to be those times when you do want to make changes to your game. And so in those cases, this is what we call making the game cloud aware. So we're extending the platform XDK, which again, you're already familiar with, you already know how to build on. We're adding a new set of APIs to enhance the game's playability, regardless of the device that it's being played on. Games will essentially be able to call an API to know that they're running from a data center and being streamed. And then if a game knows that it's being streamed, then you can take advantage of all of the other APIs to do other things to make that game's playability much more comfortable depending on what device you're playing on. For example, take something simple like font sizes, right? If I'm playing at home on my 4K TV, chances are most of the games I'm playing I can see the font just fine, although at my age it's getting harder even on the 4K screen. Second, if you're playing on a smaller form factor, the same game, you may want to dynamically change that font to adapt to the device that it's being played on. In other words, a smaller screen. So enhance the font size so that it's more readable. Think about something like a map, for example. If I have an Xbox controller, I can use the triggers to zoom in and zoom out. If I don't have an Xbox controller available to me, then I need to take advantage of something like native touch control, pinch to zoom, for example, to actually accomplish the same things. So these are just a couple of simple examples around what we mean when we say touch adaptation for input and then device characteristics and taking advantage of that knowledge to impact your game's playability when it's being played on different devices. All right, and so my other colleague Sean is going to talk to you a bit about what we're doing in building our CloudAware SDK and the APIs that are going to be available and how you can use those APIs. So I would like to introduce my colleague Brandon to come up here and talk with you a little bit about touch adaptation and enhancing your game's playability when it's being streamed.
Thank you, Gus. Morning, everybody. All right. For some of us in the room, our first gaming experience was with a gamepad or a controller. I know I started, like us probably, on an Atari 2600 with a joystick. But the new generation of gamers grew up playing games with glass controls. Whether it was on the tablet or their parents' phone, glass controls are a natural way for them to play. So for these gamers, and for those who don't have a controller, there will be glass controls for your games created through our Touch Adaptation Kit. My name is Brandon Reif. I'm a program manager on Project xCloud. Let's talk about how we reach those 2 billion gamers that Gus was talking about with little or no work. On xCloud, you'll be able to leverage the skills and tools you already have to continue to build your games. And as you heard from Gus earlier, console native is the way that you build games today for Xbox. There's no changes to the process or tools. So for console native, you won't need to change your code to publish games on Project xCloud. And because of this, you won't have to go through CERT again. Now, here's the exciting part. You'll be able to create your own custom glass control layouts. To get you started, we will provide a set of generic glass control templates for different game genres. I'll share some of those examples in a bit as we dig deeper into the TAC. I'll be referring to the Touch Adaptation at times as the TAC. Back in Microsoft, that's what we call it. So forgive me for just throwing that in there. As we thought about how to bring your games to mobile devices, the Xbox controller was our starting point. There is a challenge of the 18 distinct inputs on the Xbox controller that we have to support. And if you think about it, that's a lot of stuff to throw on one screen at a time. And there's also the lack of triggers on a phone. That creates some interesting game design challenges. So if your game relies on analog triggers, we'll need to be creative. So what is the Touch Adaptation Kit? Simply, it's a way to map the Xbox controller inputs to glass overlays. This is our standard glass control overlay. It's a good place to start since it has all the Xbox controller inputs. The Touch Adaptation Kit also contains the ergonomic foundation for our touch system. It's based around the same ergonomics as the Xbox controller. These represent the most comfortable areas for your thumbs while playing games on glass. When you see all the controls on the screen here, it gets pretty busy. Today, you design your games around the complex and finely tuned controller for the Xbox. So, I want you to picture your games behind this controller. And now think about how you could improve this without compromising your gamer's experience. This is what the TAC is all about. And I think you guys can do better than the standard layout here, and I think your community deserves better. Let's start off with the 2D platformer here, Dead Cells. It's an example of simplified glass controls. You'll notice all the touches lighting up on the screen for user input. First, you can see that we've removed all the unneeded controls from the screen and shifted the game controls to the outside a bit to give the screen more real estate. This makes it easier to see as you play. We also removed the analog stick. This was the starting point for us. For most platformers, a D-pad works perfectly. That also makes the input much less complex. And as you see here, some simple edits make a huge difference. We also remapped the weapon actions to the right hand. This makes it easier to use all the weapons in the game while running and jumping. Apart from those changes, it doesn't deviate that far from our standard Xbox layout. Well, many of you know or are familiar with Cuphead. Its looks are a bit deceiving. This game is challenging with a controller and with glass. With standard glass control layout, I can last about 30 seconds with this, but with a couple tweaks, the game becomes a bit more approachable. The first big change we made was we turned the fire button into a toggle, so it's either on or off. This allows the gamer to focus on the character and the game and the in-game action. And with this simple change, I can last a full 35 seconds now. Secondly, when we started to look outside of our core console gamers, we had some context issues. Not everybody understands A, B, X, Y, and what that means. So we created the ability to create custom icons and replace the A, B, X, Y, and all the other buttons. This is what you see today in mobile games. They use a button that looks like the action. Our Touch Adaptation Kit can really help with simplifying the customization of your game. Now, let's take a quick look behind the scenes at the code for this layout. As you can see, it's just a simple JSON file where you define control type, what the action is, and which socket to place it in. Of course, there's a little more to it than that, but it is the beginning of tailoring your controls and customizing with the TAC. In a short amount of time, you can have your glass control layout and buttons customized with the TAC here. And you might need to take it even further and replace the standard controls with highly customized inputs to match the game. Great example of the need to customize is Forza Horizon. Its driving system is highly tuned for the Xbox controller. With Forza, we created a glass control with custom icons and custom controls. We created a custom steering response curve that feels better for glass. All that work is just part of the control, so you guys get that for free. We created and tested many different controls for Forza. So, the beauty is you can let your gamer choose the layout they prefer. By clicking the icon in the upper left corner, you can select the layout that you want to use for your game. But if we want to take this to the next level, we'll need to write some code. Let's talk cloud aware and our second way to get content on Project xCloud. Please welcome Sean Farkas to the stage.
Thanks, Brandon. I'm Sean Farkas. I'm a dev working on the Cloud Aware SDK on Project xCloud. And so let's talk a little bit about what that Cloud Aware SDK actually is. So Gus talked quite a bit about console native gaming and how your existing Xbox development skills, they carry right over. Our hardware platform in the cloud, it's based upon that Xbox hardware that's in your living room. So all that you know about tuning for that platform, that carries right on over. Brandon went in depth on the Touch Adaptation Kit, building custom glass controls for those console native games. Cloud Aware SDK, that's the next step along that path. You can use it to make targeted modifications to your game to enhance the gameplay experience while you're streaming. Now, what kind of modifications might you want to make? Let's think about a game that has, let's say, just a few save points scattered throughout the levels. Well, in that kind of game, I might be tempted to save automatically when my player disconnects and then resume that save when they reconnect. Now, it's possible I've gone ahead and I've had my difficulty curve in that game tuned around having just a few save points. So in addition, once I've restarted gameplay, I might want to go ahead and delete that save that I made temporarily. So with just those few modifications, what I've done is I've enabled someone to play my game, drop out when they get to their destination, and then pick right back up where they left off on the go. If I'm building a first-person shooter, I might want to adjust my auto aim sensitivity if someone's using touch input. I might want to go ahead and take advantage of the gyro inputs that phones provide to allow people to aim by moving their device. If I'm building a driving game, I probably want to adjust the steering and brake assist for that game. And if I'm going and building a multiplayer game, I can use the Cloud-Aware SDK to matchmake players that are all in the same data center, reducing the latency between them to something negligible. So the Cloud-Aware SDK is built upon the existing Windows APIs that you already know and are familiar with. We really just tried to light those up in ways that make sense in a streaming context. The example being input, we use the standard Windows input APIs rather than building something new. So any code in your game that's already using the Windows input APIs, that'll continue to work in the Cloud-Aware context. Of course, there were a few places where we didn't have an API to light up. The is streaming example here being one of them. And in those cases, what we did is we added flat Win32C style APIs to the SDK in order to expose this functionality. And we've designed the Cloud-Aware SDK such that you can build your game once. You have one single binary that runs either on a living room Xbox or on our xCloud servers. And what you do is you can just detect at runtime which context you're in and light up any Cloud-Aware functionality that makes sense if you happen to be streaming. There's really no need to build a streaming SKU of your game. Just the one build will work. Now, there's a bunch of features in this SDK. There's basic stuff like detecting that you're streaming or detecting the client characteristics so that you can see what size of a screen am I streaming to. There's more advanced things such as the ability to build a full touch native interface or adapt to variable latency at input, and we'll talk more about those features in a few minutes. So to get started, you're going to need a dev environment. You're going to need dev tools. Now we know you already have a development environment for your games. You already have tools you work with, and we don't want to interfere with those processes that work well with you. So what we've done is we've gone ahead and we've updated the existing Xbox One development kit to have a mode where it can stream your games to your phone. We'll be providing a content test application that sits on your phone, and it serves as the streaming endpoint to connect back to your dev kit. And of course, you're probably going to want to be able to test your game on a network that has different last mile network characteristics than your local dev studio Wi-Fi. For that, we're providing a network simulation tool. And this can sit between the content test application and your dev kit. And what it does is it lets you do things like introduce latency jitter or bandwidth, for instance, to mimic a consumer cellular connection. So what would you do if you wanted to get started building your Cloud-Aware game? Well, the first step is to take your development kit and enable this streaming mode. To do that, we've updated the dev homepage that you're familiar with to add a new tab and a set of actions for streaming, so there'll be a simple switch to turn that on. Now you'll load up your code, you'll make some Cloud-Aware modifications, maybe you detect the size of the device you're streaming to and change your font size to something more legible, and then use Visual Studio to edit, build, and deploy that game just like you do on any other build of your project. So at this point, you have a potentially Cloud-Aware game sitting on your dev box. You can use the content test application on the phone to connect to that box and see how those modifications are working as you tweak and tune them. You also might want to use debuggers, right? Of course. So you have your PC, you can connect Visual Studio, you can connect Pix, you can connect any debug tools that you're used to working with to monitor how your game's working while you're making these changes. And if you want to simulate the network conditions of Wi-Fi somewhere else or a cellular connection, you can attach the network simulation tool in order to inject the different latency characteristics you might see. Now, because that's between the dev kit and your phone, you'll still be able to connect all of your existing dev tools and scripts and everything you're used to working with to your dev kit just to make sure that you can diagnose and really understand how your game's working in the streaming environment. So Brandon talked quite a bit about using the touch adaptation kit to create a set of touch controls for your game. And this works great for almost all the parts of your games. The ones that work really well just wants to see the A, B, X, Y style X inputs. And Remember, he even showed using the touch adaptation kit to do something like create a customized driving layout with a slider control for steering. And that works great for the majority of gameplay in a driving game. Our user research shows that on a mobile device, however, there's a few places where people expect a different input paradigm. The one we see most often is menus. When a menu comes up on a phone, people really just want to tap at that menu. On the same note, if a map comes up, a natural reaction we see in our testing is people interact with that map using mobile phone gestures instead of using on-screen glass controls. So while the touch adaptation kit might be all that you need, there might be a few places in your game that would benefit from building a full native touch interface. And the CloudAware SDK is designed so that you can go to those sections of your game. You can touch enable a menu or a map. But it's not all or nothing. You can mix and match. So if your game has a menu that would benefit from touch, but the rest of the game works perfectly well with the touch adaptation kit, that's a really reasonable and common way to do things. Now, we've used the standard Windows input APIs in order to make this work. So if you happen to have code that's already written to handle Windows Touch, that code just works on xCloud. So one example of this is we took Minecraft, which has the touch interface and its Windows application, and that code actually still exists in the Xbox version. We put it on our servers without touching a single line of code. We just took the binary and moved it over. The full touch interface lit up and worked exactly as the studio had designed it. Now, even better than this, on Xbox, we unify mouse and touch input. So if your game has mouse support, it might already have support for xCloud touch input as well. The Xbox shell, for example, happens to have some mouse support built in. And it turns out that one of the first ways we knew that our touch APIs were working was we deployed a build, just a daily internal build to our server, and suddenly we were able to scroll through the games list on the shell and launch a game by tapping it. And again, this is without touching a single line of code in the shell. The shell has no idea what touch is, and it had no idea it was being streaming. That just worked. Now, when you work with the touch adaptation kit, it's very likely that you're going to need to build multiple different touch layouts for your game. If we think about a game like Halo, the majority of that game, you probably want to use a first-person shooter layout. But if you do something like hop into the Warthog, a set of layouts that's more customized for driving, that's going to provide a much better experience. You could even imagine a third layout if you jumped into the back of the Warthog to man the gun, or if you're using a different type of vehicle, like one of the flying vehicles in that game. So, well, how do you make that work? Now, the first start is to use the touch adaptation kit to build the full set of layouts that would apply anywhere in your game. Then you take those layouts and you upload them to the xCloud servers. We'll go ahead and we'll tie that set of layouts to your game. And what that enables is anytime someone launches your game on an xCloud client, those touch layouts will automatically download from our services to their device. Now, Brandon talked quite a bit about how this was just some JSON files, well, mostly just some JSON files. So the bandwidth requirements here are not very high, and your players probably won't even notice this happening in the background. So now we're in a state where your player's phone has all of the layouts that might work in your game. And what we need to do is enable the game or the phone to figure out which layout's the best for any given moment of gameplay. So what we've done is we've provided an API that you can call in your game and say, this is the best set of glass controls for any given game state. This is effectively just a one-liner when game states transition, and I really truly mean it's a one-liner. You don't even have to go ahead and check to see if you're streaming, because these APIs, they act as no-ops if you're playing in a living room. There's also going to be times when you just don't want glass controls on the screen. You can imagine that you're rendering a cutscene, or you've done the work to build a touch-enabled menu, and having glass overlays on the screen is distracting from the frames that your game is rendering. So in those cases, we've got an API that asks the client device to remove the glass controls. And you can have the full screen to yourself until your game transitions to a state where it needs inputs again, at which point you'd call the original API to ask for the right set of controls to go back on the screen. Now let's walk through the Halo example in a little more detail. Now when you start the game, you might be in a battle with a bunch of Covenant, and so you say, please show the glass controls appropriate for a first-person action sequence. Now, it might be a particularly big battle and it ends with a cutscene. So when that first frame of the cutscene starts, you might say, please hide the glass controls. Let's let this cutscene play out without any overlays on the top of it. On the last frame of that cutscene, you'll now want to put the glass controls back up because the player is going to take control of their character again. And so you just say, now it's great, let's put the first-person action controls back up. Supposing that I go ahead and use those controls to run over to a nearby warthog, when my game senses the transition from first-person to driving state, it says, great, go ahead, put up the driving controls. And throughout this whole process, what you're really doing is you're just informing the client device, this is the current state of my game, and I have a layout which matches that state. Right? You're not really doing anything other than that, so it's a really simple change generally to make to the game. If we think a little bit about what happens if I'm on my client device and let's say I'm interacting with the game using a Bluetooth controller. Well, it'd clearly be extremely distracting if every time your game calls this API, I pop the set of touch controls up on the screen. So what we do in this case is on the client side, we'll notice that the player is not using touch inputs and will not display any glass controls even though you've called this API. So the observation here is that these APIs, they're providing a hint. They're saying, if someone is using glass input, this is the best glass input layout for them to be using. Now, although the client device is not necessarily reacting in real time to these API calls, it is paying attention. So if I'm playing on a Bluetooth controller and the glass controls, they're not toggling back and forth in real time with your API calls. Instead, it's remembering what the most recent set of glass controls you asked for were. And if I disconnect that Bluetooth controller and start interacting with touch on the screen, that's the set of controls which will come up. All of this logic is on the client side. So what that means is that your games don't need to be aware of what type of input the players are using. You don't need to know they're on Bluetooth and they just switched to touch. You don't need to know even if the game is, or if the device they're on is touch capable. From a gameplay perspective, you're just going to see X input APIs. The touch adaptation kit, those glass controls, they'll send down A, B, X, Y. They'll send down left trigger, right trigger. That's what you see. You don't really need to care how it got there unless you want to. So let's switch gears a bit and talk about multiplayer. Now, a lot of your games already have a bunch of code written to handle latency in multiplayer scenarios. And the xCloud platform will allow you to reduce your backend latency by placing your game servers in the same Azure data centers as your players. Now, how do you do this? Well, you start by using Azure to host your multiplayer game servers. We'll then be providing an API, which you can call from your game, to figure out which data center each instance of your game happens to be running in. With that information, you can go ahead and you can select the multiplayer server that you have, which is hosted in that same data center. And that allows that instance of your game to communicate with that game server using the Azure Fabric rather than going over the public internet. Similarly, you can go ahead and you could imagine saying, I'm trying to matchmake 16 players in my game, and look, here's 16 players all in the same data center. Right? They might even be in the same rack, right? And you can make a game where they're all connected together with very, very low latency between them. The algorithms that you already know about for multiplayer latency, don't forget about them though, because they're going to come in handy when we start talking about the latency between a player and the game. Now, we host your games in the Azure data center, which is as geographically close to your players as possible. But the speed of light makes it just a simple fact of life that the time between when your player presses a button on the controller and when your game sees that button, it's going to be slightly longer than if your game was in their living room. And on the same note, the time between when you render a frame and when your player sees that frame, it's going to be slightly longer than the living room. Now, because xCloud is built on top of Azure, we take advantage of its size and its scale to make sure that your games are physically close to the players. But you may want to use those latency compensation algorithms to enhance the gameplay even more. Now, being physically close means that these games, they're playable, they'll work. But if you have an algorithm you've already engineered and you already know how to use, it might make sense to move it from the networking stack to the input stack and see what happens. To do that, of course, you're going to need some inputs to those algorithms. And we're providing you an API that lets you see the instantaneous observed latency that that player has at any moment in time. Using that, you can tune and do whatever adjustments that your algorithms require. And when you've done that, you'll probably want to play test the results. Using the content test application and the network simulation tools I mentioned earlier, you can go ahead and you can see exactly how your playtesters feel about the algorithms that you've implemented on the input stack. Once you've gotten those playtest scores back, it's going to be useful for you to see what the actual real-world network conditions were that your playtesters saw. And the content test application allows for exactly this. So you'll get your raw playtest scores back. You'll be able to go to the device that that score was created from, and you can see exactly the history of their network conditions. And maybe that'll lead you to do some more tuning or decide that your algorithm is working great and it's time to ship. So I've just shown you how the Cloud-Aware SDK allows you to make modifications that enhance your game's gameplay when we're streaming it from xCloud. Keep in mind that many games benefit from just a few targeted modifications. You get a lot of bang for the buck from some of these, and they provide a huge improvement in gameplay for the kind of effort that they require. Now, most notably, as Brandon talked about, providing custom glass controls is a huge improvement in gameplay. Now, the standard glass controls, they work. You can use them, and they play fine. But if you go that next step and you move the positions into places on the screen that don't interact with your gameplay, if you create custom control types like the slider for steering or a toggle button, if you change iconography to something that matches your game's experience, it really does help the gameplay quite a bit. And if you go a step further from there and use the Cloud-Aware SDK to build different custom layouts for different parts of your game and automatically switch between them, the jumping gameplay experience we see is tremendous. Now, our user research has shown that players, when they see menus, they touch them. And I don't need the user research to tell me this. I've been on the xCloud team since it formed, and to this day, when a menu pops on the screen, I find myself tapping at it. The Cloud-Aware SDK lets you build touch-enabled menus, and that really helps quite a bit with the experience that your users have with your game. And remember, since we're using standard Windows input APIs and we have mouse and touch unified, it's quite possible that many of your games already have support for this baked in or very close to already there. Another thing you might want to consider is the legibility of your game on different devices. So imagine that if you're on a small phone, you might want a larger font size. It's useful to use the Cloud-Aware SDK to detect the size of the device that you're streaming to and do some design tweaks in order to make sure that your game's readable and legible everywhere it's streaming. Multiplayer games and games that use servers in general, they really benefit from using the Cloud-Aware SDK to collocate servers in the same data center and use our Azure network fabric to talk rather than going over a public internet. By doing this, you can reduce the ping times between them to something really negligible. And finally, you should anticipate that your players might have shorter gameplay sessions when they're playing on the go as opposed to when they're in the living room. If your game doesn't already support drop in and drop out, or if there's a distance between save points, it might benefit quite a bit from supporting the ability to save when a player disconnects and resume when they reconnect. You know, if I'm playing a game on my ride to work in the morning, I'm going to disconnect when the bus gets there rather than waiting for the next save point and getting up at the stop down the road. Now, these are just a few things that you might do with the Cloud-Aware SDK. This is certainly not an exhaustive list. Hopefully you've got some thoughts going on about ways that you might want to enhance your games when they're running on the xCloud servers. Now, this SDK is in testing now, and we'll have more news about wider availability soon. But now, I'm going to turn this back over to Gus.
Awesome. Am I back on? There we go. Awesome. Thanks, Sean. Thanks, Brandon. I think they gave some pretty interesting insights on how you can change your game using, as we mentioned earlier, input capabilities and device characteristics to impact the game when it's playing on different devices. So, as I mentioned, it's an exciting time. We are landing hardware in our data centers around the world today. We're manufacturing blades and racks. I thought it'd be cool to show what they look like to reach a global footprint. Hopefully today, we've been able to share with you what Project xCloud is, what we're doing, what we're thinking, and even more importantly, where we're headed to help define that next evolution for gaming and the gaming experience. Just want to leave you with a couple of thoughts before we're done today on the platform and what we're building and those capabilities that we just talked about. So today, Brandon and Sean gave you some initial idea starters to start thinking about for how you can adapt your game to when it's being streamed to different device types. You can do this simply by making no modifications to your code. Simply upload it and stream it, for example. You can use things like enhancing input using glass controls and touch overlays, still not having to break open the game bits to do so, but enhancing that gameplay when it's on different devices. You can use the Touch Adaptation Kit to customize your input experience, tailor it to your specific game to improve the gameplay. And most importantly, just help that game adapt to the device that it's being played on. Now, at the beginning of the talk today, I mentioned there's 3 things that I'm hoping that you'll take away from this today. Hopefully, we've given you a little bit of a peek on where we're headed. But number 1, we're building a platform which will enable you to reach your consumers on a global scale. We're built on Azure, and that means global scale. Number 2, employ a write once, play anywhere strategy on any device. And number 3, leverage your existing skills and tools to do so. You all already know how to build on the Xbox platform. We're just enhancing that capability to reach a completely new set of consumers. So over the years, you've been investing in us, in our platforms, in our technologies, in our tooling, and now we want to invest back in you. Everything that you've learned to build on the Xbox platform can now be leveraged to unlock the opportunity of reaching those 2 billion gamers. And this represents those 2 billion additional gamers. Back in October of 2018, we made the promise that the games you're building for console today would be able to come to a device like this. And today, that promise has become a reality. Our platform and our services are up and running in Azure data centers. We're testing them now, and we'll be bringing them to you soon. And so thank you, everybody, for your time, for coming and hearing a bit about what we're doing today in Project xCloud. We would love to hear from you. I know there's probably tons of questions, and we're not going to be able to address all the questions here. And we want to make sure we capture your feedback. Do the surveys, please. But we put up a questionnaire that you can go to. Put down your feedback. Put down your questions. We'd love to hear back from you. So thanks again for listening, everybody, and enjoy the rest of your GDC. Thank you.